Okay, in this video we're going to be going over section 7.2, which we're going to be dealing with the Leontief model. Remember, I pronounce it Leontief. It's probably pronounced better somewhere else. Using a consumption matrix. So let's go ahead and dive into what we're dealing with today. All right, remember the input-output model. We're going to model that analyzes the flow of goods among sectors in an economy. So our first formula that I want you guys to be responsible for is this right here. Remember to go ahead and pause the video to write this stuff down just so you can just so you can stay with us here. I also wrote little hints here that how the production matrix will be a column matrix as well as the demand matrix and then a square matrix. Now most of this information or most of this formula is going to be very calculator driven. So if you have a TI 84, 83, what have you, with the matrix operation function, when you plug it into your calculator, that's what you're going to be doing. The production matrix minus the consumption times production. So that's really all you're going to be doing from the calculator standpoint outside of entering in the matrices. So I'm about to change the page, so if you will, just pause it if you need additional help. All right. Okay. The total production of a company in the month of September is 500,000 worth of goods and 150,000 worth of services. Calculate the demand. Well, using our powers of observation, we know that we're talking about total production, okay? And we're going to find the demand, which means we're going to be dealing with that formula that we just dealt with. P minus CP equals D. Now, a couple of things to note is that in this problem, you'll pretty much always have, and I say pretty much, you will have the consumption matrix, okay, and that's going to be plugged in for C. And then notice that you have 50 or 500,000 and 150,000. Okay, now that will be written in a column matrix. Now the thing to remember is that the 500,000 is worth of goods. Okay, now in our consumption matrix we have goods over services, so that means in our production matrix it has to follow along that. So when we plug it into our calculator, it's going to be 500,000. Let's see if I can do this. I'm writing with my mouse here. Pretty bad. And then 150,000. All right, though. And that's going to be minus my consumption matrix, which I'm just go ahead and type it in word for word or number by number, so to speak. 0.17 and then 0.15. And then I'm going to multiply that by my other production. Remember, production goes in twice here. All right, so basically I'm just going to enter that into my calculator and hit enter. And so I'm going to give you a second to pause the video to do that. So pause it right now. And my answer is that right there. So that tells me my demand. Remember, demand tells me that or what amount of money is going to the consumer. All right, let's go to our next formula that you're going to be responsible for. The next formula is going to be this right here. Okay, and this is when you know everything except production. So you're trying to find the production here. Okay, now notice that everything is written in a column or square format, so that's just going to kind of help you. But the thing to pay attention to is what is called the identity matrix. We haven't talked about that yet, but we will in a second. Now, remember, all these are matrices. So in our calculator, our graphing calculator, when I move this square away, that's all you're going to be typing in. Okay, that's really everything once you entered in all your matrices. Now, one thing to note is that this -1, okay, this -1 represents what is called the inverse of the inverse function of that. Now, in your graphing calculator, it's going to be the key that is x -1. That is the inverse key that we're going to be using on our graphing calculator. Okay, remember, I'll give you a second to, or just pause the video if you want to keep writing this down. All right, let's once again talk about the identity matrix. All right, what is the identity matrix? And the identity matrix, in short, is this. It is a matrix where you have ones going down the main diagonal with zeros everywhere else. Okay. Of course, we can go into a big long example of why that's the case, but it's just easier just to give it to you. So notice that all the ones are going down the main diagonal with zeros everywhere else. And on this 4x4, notice all the ones going down the main diagonal and zeros everywhere else. So that's really the identity matrix. Pause it if you need to for me to go slower. All right, moving on. The demand for a company in the month of September is this, and then it says calculate the total production. Okay, so now we're going to be using our formula that we just learned 5 seconds ago, literally. All right, so once again, here's my consumption matrix. I'm going to plug in here. Now notice that my identity matrix and my consumption matrix is going to be subtracting, so that means my identity matrix must be the exact same dimensions. So that means I'm going to be dealing with a 2x2 identity matrix. So that's my identity matrix 1001 minus my consumption matrix, which is 0.05. Remember, I'm writing with my mouse here, so it might be a little messy. There's my consumption matrix. Here's my parenthesis, -1, inverse, and then my demand matrix. Now remember, demand matrix needs to be written in a column, and I'm going to put 300,000 over 50,000 because of the fact that my consumption matrix tells me to put my goods over services. All right, so this is my production. Let me put my P in there just to be thorough. And so after we calculate everything, when we put it into our calculator, we get an answer of this right here for our total production. Remember that our total production, those numbers are always going to be higher than anything or than our demand. So there's your answers right there. There's your questions. And so if you have any issues, let me know the next time you see me. Thanks for watching. Bye-bye.